panel discussion that brings together data science leaders to start the conversation on what is needed to make data science a reality in production. So let's welcome Tanuja Ganu from Microsoft Research, Goda Ramkumar from Swiggy, Smita Oja from Google, Janani from Bain Company, and I'm told Matangi has joined, Matangi from GoFood Gojek. Let me just check on that. So this panel will be moderated by Sharon from Intuit. Hang on, guys. Let me just find where Matangi is.
Has Matangi joined? Cool.
Yeah, she just pinged me and said she joined, so I'm just trying to find her. Otherwise, I think you can get started with the questions. Let me
No worries.
find her. Yep.
Great. Okay, so good afternoon, everyone. I'm Sharon. Thank you all for joining. We have an awesome panel discussion lined up for you guys today to discuss the challenges in productionizing machine learning. And we have 5 illustrious panelists today from different walks of life, different organizations who are going to help us go deep into this problem statement. Now, we just have 30 minutes, so I'm going to kick it off with first understanding how organizations actually identify the key problems that should be solved with data science and which have the maximum customer impact. So for that, I'd want to kick it off with Goda. So Goda, in your opinion, what are the best ways to generate ideas for data science models, and what are the methods that you've seen teams use to narrow in on that? Goda, I think you're on mute.
Am I audible now?
Yes. Yeah, now we can hear you.
Yeah, okay. Yeah, so what I've seen working with several startups when I was a part of X to 10X is usually the way to go, or way people go is they go from data to problem, saying now I've collected all this data, so what are the problems I can solve with this? But the best way to go is actually coming from the goal and the problems to where data can be leveraged, right? And one of the models which helped us a lot here is what we call the drivetrain model, where all the different parts of the organization, whether it's product, business, data science, analytics, all come together and take a goal and ask the question, for achieving this goal, what are the important levers that we have? Because important levers are the decisions you make. And what information will empower us to make those decisions? Because usually what data science does is either give information to make decisions or make the decisions itself. So that's a very good framework to identify the key problem to work on is what I figured during that journey.
Awesome, I love that. And another aspect is also about the team structure, right? So, I mean, this is close to my heart because I'm a product manager, and I've seen teams struggle with this. So, this is a question to Janani. And Janani, in your opinion, what have you seen is the best way that all these functions like product, data science, engineering, analytics, design should all coexist and work together?
Am I audible?
Yeah.
Yeah. So I'm currently with Bain Consulting, which is a unique setup compared to all the product companies that I've worked with. But I think that the roles still apply. What happens is we have to go into a new company and a new context and quickly deliver business value as part of this consulting framework, right? So one thing that really helps us is we have data scientists that are embedded along with consultants who go in and just quickly figure out what the pain point is and how to solve it. So we have really lean teams. So there's no program manager, product manager. A portion of the product responsibility is with us. So it's sort of this really nice thought partnership where we figure out how to solve the larger goal. Right. So it's in this setting, it's difficult to get stuck in this silo of just solving the business, solving the data science problem. And so a lot of times these sort of heterogeneous teams where there's someone from, say, a more engineering background, someone from a data science and analytical or statistical background, than someone who is sort of playing the role of business and product, and someone who is actually helping us, steward the data. So it's a unique setup, but I think that that's actually how we should be working, because the proximity to the problem and understanding it in context is very essential to building bridging the gap to get to actually delivering value.
Got it. I'm fearful for my role right now because I'm in product. But anyways, Goda, do you have any viewpoints here?
Yeah, actually, I think it also depends on the stage in which the company is. Because when you're in the early stages, having a central team which has view to a cross-section of problems across the org, so that you can recognize the right patterns and solution across, kind of works out better. And later, when the organization becomes more mature and each vertical is very nuanced in itself, then kind of embedding data science within those verticals kind of evolves. But before that, I think the order of creating these teams is also important. That before data science, what comes is actually the data engineering function, which has puts the data in the right form in the data platform for you to even leverage the impact of data science. And once the team is in place, what I've seen working is, like Janani pointed out, as pods where you're solving a problem and all the different people with different skill sets, whether it's product, data science, engineering, analytics, working together as a pod to achieve that one particular goal is where it works out the best way.
Got it. Thanks. Okay, so now that we're clear on the right problems, how to identify the right problems, let's look at, even before going to production, how do we test this out? So this is for you, Matangi. In your opinion, now what are the best ways that we can actually test these hypotheses before we actually invest heavily into data science, and if there's any way to look at key lead indicators of success?
So I want to start on this with the basic way here, Sharon. So one of the things is we should create offline measures of which emulate the business problems. That is the very simple and basic way of solving for it, because experiments are costly, and creating an offline emulation and kind of understanding how the models perform and what are the results for the models, socializing this with the stakeholders, kind of coming together and understanding, okay, this is the expected outcome of the model, will put everybody on the same page and also give visibility to a lot of people and transparency in the entire model development process. And more advantageously, this will also give you some leeway as a data scientist to kind of go back and tweak some of these parameters if the business metric is not measured. It can set the right expectations to folks around, etc. Right. The other way of doing it, which is extremely expensive, is create a very fast infrastructure where you can deploy models faster and experiment faster. But the problem with that is you have a hit and trial mechanism, and people could also perceive who are working around you as data scientists knows this hit and trial rather than a very well measured process. So one of the important things of while you're working and building these models is that as long as predictive model, as much as you're building predictive models, what is also important is predicting the outcome of these models, predicting the behavior of models, and deploying models which are more predictable from that perspective becomes an important deliverable in itself. So rapid experimentation is important, but not at the cost of randomness. That's how I would say that we should go about understanding the performance of the models and the experimentation behind it.
Could you just quickly also tell us a little bit about the offline, methods, just for my understanding?
Yeah, sure. So for example, let's say we are, take a very simple use case of building a targeting model, right? Like let's say we are, cutting a user file and going to target users who have high propensity to buy a product, right? Now, and hence you would need to know how many users you would be targeted, and if they actually get the campaign through digital or a non-digital mechanism, what is their expected conversion rate like, and if that is the expected conversion rate, what does the actual revenue look like? So maybe you spent $50,000 on the campaign. I want to get $60,000. I want to get $55,000. Two simulations generated offline would tell you whether the ROI is worth it or not worth it, right? So I agreed. In some cases, take an example of recommendation engines, right? So it's very difficult to emulate a recommendation engine as is, because if you don't recommend, you would not know how people would have bought, right? So that problem is there. Even those problems can be overcome by, again, having hypothesis that says that, okay, in past, if a certain product has been bought by the user, are you targeting those products to that user? Maybe the conversion rate will be higher than what you expected, but at least relative conversion rates. The other thing that I also want to highlight here is, whenever we are kind of experimenting with these models and heavy duty machine learning neural network models, sometimes it's very easy to get fooled by the complexity of the models. It makes sense to build a simple, random, and the most dumbest rule possible. So that you put your dumbest rule and then say, for a lack of better example, let's say even the recommendation system. Let's say if my rule is going to give you recommendations based on just frequency distribution, would my model beat that at least, right? So you make a dumb rule again offline, and then see if your supposedly complicated, complex, mathematically sound machine learning model will beat that offline, and then try and put both of them together online, so that you're not getting fooled by the complexity of these mechanisms, and these mechanisms do have an incremental edge.
Got it. Love that. Thanks, Matangi. Okay, so we've covered problem identification. We've covered testing into hypothesis. Now we're ready to do in production, guys. So the next question is to Smita and Janni, and let's start with Smita. So Smita, in your opinion, like, what's the workflow like when you're building a model, and what are the areas that people spend the most time on?
So there is, we are discussing like data science. So there's the data, which is a big part of it, and then there is a science which gets applied on data, right? So if I look at the data, the first thing you start with, the step one, is identifying, after you know the problem, identifying what data do you need, which data sources do you need, how will you fetch that data, how will you clean that data, how will you even assure the quality and the completeness of the data. This is the basic foundation which forms the majority of your work. Because once you have that complete data, you have assured that it is the right set of data sources, then you start building the model on it, on the training. You start creating your training sets, you start creating your models, you start creating your testing sets, and then you put it in production. So this whole pipeline, first is the majority is the generating and cleansing of the data set. The second part of the pipeline is how you can test multiple models at the same time. And that's where the science comes into picture. And then the final part is, okay, now I have tried out multiple models, I have my clean data, and now I'm ready to go into the production. So I would say it's about maybe 70% work is in the data, 20% work is in the science, and the 10% work is, okay, now finally go out in the production.
I know you just demystified it for many of the people online. I think I remember you saying that there's a myth that data science is all glory and scientific, but actually there's a lot of work that goes into cleaning the data itself, right? So Janni, do you have any viewpoints here as well?
Sure. Jumping off of what Smita just said, we tend to think of it as a modeling problem, right? But oftentimes what happens is, as practitioners, the work that we put in before and after the model is what is really crucial to deliver value. So one of the things in defining, beyond, of course, making sure that you have the right data, is really how are we going to keep ourselves honest in terms of what problem we're going to solve and what is the ROI for the problem. So what we've found is that we just start by establishing a very simple baseline, very similar to what Matangi said, which is, if there's something simple you can do, just start there. that baseline will keep us honest in terms of how much effort we're going to put into just solving for predictive accuracy. If a moving average works, then why not, right? So really just spending some time as to what that baseline looks like is important as part of just defining the problem. And a lot more things need to go into the preparation step. Similarly, after you build the model, that the serving and monitoring is super important. So we need to think through sort of how often does the model need to be refreshed? What does drift look like? What is acceptable latency for scoring? All of those are also very important. I think the more time we spend in the before and after as just data science practitioners is very valuable.
Got it. Great insights there, guys. Thanks. So the main topic for today is challenges in productionizing machine learning, right? So what I'd like to know is now, what are the current gaps that we see in the industry between a good ML model and a production ready app? And Tanuja, do you have any thoughts here? We'd love to hear from you.
Yeah, can you hear me?
Yep.
Yeah. So there is definitely, as in generally, lot goes as Janani said, right, after the model stage as well. As we do have a good model, but there are a lot of other work items and tasks involved before putting the model in the actual production. That includes the software engineering, DevOps work or machine operations, and also including the business team on board and getting the right stakeholders on board. So let's say now we have a good machine learning model and we know that we are ready to get into a production system. What is firstly important is to understand what would be the load on the system. So understanding the load implications of that model, and based on those load implications, understanding the cost and infrastructure implications associated with that and provisioning for that. So that's again a big component of having a successful model into the production. Similarly, there are a lot of other components which are involved, making sure that whatever model that is worked on, so training data, so the production input that we are seeing from, it's coming from the same distribution as the training. Otherwise, there is a high chance of completely failing the model when we put it into the production. There are a lot of other parameters, including how are we going to monitor the model, or how are we going to continuously look at the evaluation in the production system. So defining right KPIs in terms of the time that it takes for inference, or the kind of output that is giving on the production system, and getting that evaluation metrics in real time for us to understand whether there are any interventions which are required while the system is in production. And the last and the most important point, I think, is how are we going to introduce the model into the production system. So there are multiple ways in which we can do that. Either we can do that as a shadow system, wherein without actually serving the model in production, we can continuously monitor, take the input and provide the inference, and look at how the evaluation looks like, and then decide whether we are ready to get into the actual production system or not. Or also introducing it into a gradual mode, where instead of serving the model for all the user base, we can choose it for serving a fraction of customers or fraction of requests, so that we would understand that how the model performance is looking like, whether it's catering to the load and stress which is required, and whether it's giving the right performance or not. And then when we are really satisfied with all these kind of parameters, we can finally get the system and the ML model in full production with all the users and all the requests.
Great, thanks, Tanuja. Thanks for enlightening us about the gaps. Now I'm going to pause here. We've talked about, problem identification, testing the hypotheses, productionizing, the workflow, gaps, etc. But wanted to bring out like one of the hot topics that we've been hearing for a while now, right? Which is around user privacy. And would definitely like to hear from Smita on this, on how she feels we can handle user privacy issues in data ingestion and testing. So Smita, I would love to hear your thoughts.
Yes. So I have worked with a lot of enterprise data. Enterprise data means these are the company, this data is owned by the company and they are just using our software. So this is where the rules and regulations and following every single thing and like dotting your I's and crossing the T's is very, very important. So the first thing is first thing we want to understand whenever we are touching any data is, do we even have permission to use that data, right? Who is the owner of this data? Who's the user of this data? Have they given us the consent to use it? Secondly, what are the fine lines of that consent? Because many times they will say yes, but XYZ. And all those but XYZ has to be built in your system. It cannot be done manually at any point. So your system has to be robust enough to identify all the buts. And those buts are very particular about it, right? They are like, you can store my data in a particular region, or it can't even go outside India. You can use my data only for my purpose. You can have my PII flow through your network. So data in flow and data at rest is another dimension of privacy setting. So how you encode your data, how do you remove PII from your data? Where can the data reside? At what level of aggregation can it be do? And even after that, what can it be used for? Right? After all of this, it's like, hey, yeah, once you create this aggregated model which has hundreds of customers' data in it, or thousands and tens of thousands of customers in it, hey, but make sure nobody in another country gets to even see my aggregated data, right? So those are all the things that has to be part of your first part of data pipeline, as well as in your model learning that you incorporate. And the second, finally, I think it is also very important and a very expensive process is a data wipeout. Every company which owns the data will tell you, I am leaving this particular software, or I am changing my policy, and now you need to clean my data. And after that, your models all get reset, right? Because you have to rebuild all the models. So, we all have, I think, lived through the GDPR phase, which was a big phase in 2018, where all these data regulation rules even put a lot of re-architecture of our systems in order to support those kind of requirements. So I would say all of these designs have to be part of the initial design. You cannot tax the systems of considering the privacy can never be the second thought. It has to be the day zero thought that goes into the system.
Got it. Yeah, we've also been through a journey at Intuit, so with CCPA and stuff. So it's really close to heart, the amount of effort that we've had to put in for those kind of rules and regulations. So thanks for that, Smita. Janani, do you have anything you want to add there from a different point of view?
Yeah, absolutely. I was previously with LinkedIn, and we were going through the same GDPR, CCPA cycles. Absolutely agree with Smita. This is not something that can be easily done in hindsight. So you need really good, like if you have to go in and delete a certain, let's say you have to deal with right to be forgotten, you need strong lineage mechanisms to actually track through the data. So this is not something you can do in hindsight. It has to be built into the design of the data pipeline itself. And all these privacy regulations are not going anywhere. So I think thinking through governance and data protection is becoming increasingly important for enterprises and a lot of companies that are starting to invest in data science and machine learning. In addition, I think also thinking through what the machine learning model itself is doing. A lot of adversarial attacks have happened to actually expose new kinds of ways in which models can leak member information. So I think it's a great area of research, and I think it's going to uncover a lot of interesting things for us in terms of, are our explanations leaking data, or is there some sort of member inference attack that's possible? So all of these become very interesting to deal with as they come. But the important thing is to put in the safeguards so that when you discover it, you can do something about it.
Totally agree. As I said, this is close to heart. So great. So guys, we've covered, again, problem identification, testing the hypothesis, productionizing. We've touched upon privacy. But now let's say we want to apply this not just to teams, but to an organization's DNA, right? And I'd love to hear about this from Goda and Tanuja. And let's start with Goda. Goda, how do you feel like organizations who are not used to, implementing data science models can transition into becoming an ML AI focused organization?
Right. I think one of the first steps which we alluded to in the first question as well is to make data science a part of the decision making group, right? It's not the ask that should come to data science, but data science should have a seat on the table in the problem selection that we need to focus on and the decisions that need to be made. I think that's the very first step.
Right? We call it being in the kitchen and Intuit. Bring them into the kitchen.
Yes, kitchen table, oh yeah, dining table. Uh, and I think also the second part is how do we respond to findings and what happens in experiments, right? Because even if experiments fail or null hypothesis true, it's also a result, right? And how do we treat such findings, and what are the questions as leaders you ask when such findings are revealed is very much part of that fabric of building in that culture, right? And the third point I would say, I mean, this is specifically true in case of Swiggy, is we have this initiative called like AI for all, right? That is about enabling the entire organization to leverage data to solve the problems. I think half of that problem is solved if your data pipelines, if the platform where you deploy models, all that is enabled to such an extent that now somebody who wants to even test a hypothesis or wants to build a model for something and try it out, you're enabled to do that, and you're not always dependent on a small group of people to kind of try out different things, right? I think these three would make the key points. And just the last point is how you measure impact. Whenever you're making certain changes or taking certain decisions, how you are measuring the impact and creating that feedback loop to learn from is very much a part of being a data-driven organization.
Got it. And let's hear from Tanuja also. Tanuja, how do you feel about organizations transforming themselves?
Yeah, actually, Goda covered a lot of interesting points. So I think it's kind of a cultural change to move from the experience-based decision making to data-driven decision making. And for that, what is really important is from top to bottom in the entire organization, people do have access to the required data on the basis of which they can make their decision. So it's kind of a cultural change which need to as in percolate throughout the organization. And other important point which is related to getting this cultural change in place is in most of the current organizations, what we see is data sits in silos. So there are different departments, and every individual department would have their own data, but no one else would have access to it. And hence, a lot of ML problems when we decide to solve, they have these local optimizations, right? As in, you cannot get a complete picture of or get the true objective outcome achieved because we do not have even view of the entire data. So having this kind of standard platforms where you are able to kind of break those silos into the data compartments, and also bringing the different stakeholders from different departments into looking at data science problems, starting from the business people to technology people to data science people, so that the overall objective can be solved rather than looking at very narrow focus problems. So that's like one change, I think. The other problem is how we kind of choose which problems to solve using data, as in choosing the right AI problem to solve with is also important, because a lot of times since there is AI buzz, people tend to kind of start with whatever low-hanging fruits which are there, but then the results they see is incremental results, and hence very disappointing for people, saying that we have put so much of effort in data science, but we are not getting required output. So really having that methodical approach to see that what is the value, commercial value or business value you are gaining versus the amount of effort that we would be putting in solving a problem, the complexity of the problem, the infrastructure requirements, and all those bases, right? And having the right prioritization to choose which problems to solve is important. And as Smita rightly pointed, as in having the practices in place to make sure that data privacy, security, access management, all these things are in place right from start. So that's also another important thing to having the AI/ML DNA in the system. And I think just the last thing that I would cover is taking into account all the ML practices. And most of these companies do have software engineering practices in place. But if we are really want to go data-driven and AI-based systems, we need to have ML ops practices in place. And also we need to have all the infrastructure and the capacity, compute, all the requirements which come along with building these data models and AI models, those are considered and taken into account early on before even having high ambitions on solving difficult data and AI problems.
Got it. Thanks a ton, Tanuja. I think we're almost out of time, guys. But what I wanted to do is, and thanks so much for all the great insights. Go around the table, quick snapshot or quick learnings that you guys have had. One in terms of either a failure which you've learned from, or one really good success story. You guys can choose whichever. We could go around the table. You can start off with Matangi if you want to share.
Okay, we've got like 10 seconds on each of you, 15 seconds on each of you. Go.
Radhika is like timing us now. Matangi, do you want to share a quick success story or failure which you've learned from? Can't hear you. I think you're on mute.
Okay, if you give me an option, I'll share a failure story. So, hello, are you able to hear me?
Yeah, now we
can
can
hear you now, Matangi.
Now you're able to hear me, right?
Yeah.
Okay, so if you give me an option, I'll go with the failure story. Success is well talked about.
Yes. Can't hear you, Matangi.
Yeah, sorry. So this was a initiative we were trying to drive through machine learning models in terms of doing it. Hello?
Let's move on.
I think,
turn
yeah,
the web possibly. Hello? I
we're having some
dropped. Yeah, she
Matangi.
dropped.
Yeah. Okay, cool. Let's move on to Goda then. Goda, if you want to share.
I think I'll also go with the failure story only to start with. So basically, we had this fancy algorithm which, like when I was in ride hailing, that matched passengers on a pooled cab. And what we missed out was the part that what is being communicated on the UI to the customers, right? And we were trying to, pool passengers, aggregate all fancy algorithms done very well in simulation. But because we missed out the part as to what the customer is seeing, a lot of customers, dropped off and we didn't see any benefit at the back end. So I think missing out the 360-degree view of the problem is something that I learned from that. And
Got it.
We should have considered.
Smita, 10 seconds.
Yeah. Okay. So my expertise is in real-time anomaly detection, and I think it has been successfully applied in service health as well as in, detecting the security breach of any company, like what happened with Twitter this week. So the real-time anomaly detection, I think, is a very powerful set of algorithms there.
Awesome. Tanuja?
Yeah, so I would go ahead with the success story. So it was in building the decentralized or democratic demand response model for my energy problems. And I think it had the all right ingredients, I would say, of building a good ML model. So first of all, as in it was well aligned with the commercial and the business goals. We wanted to deploy this solution on embedded devices, which are like low cost, low compute devices. And all those considerations of deployment constraints were taken into account right from start. So that was really useful. And the last one was that since it was like on such a constrained device that we wanted to do the deployments, we had kept the models very simple, and those simple models generalize pretty well. So I would say that it had all kind of right ingredients included.
And lastly with Janani.
Sure. I think for me, much of the learning has come from moving across sort of enterprises with a product associated, and then moving to smaller companies, startups, large scale data, smaller data. So I think one of the early lessons for me is let's say you learn some techniques that work in large scale data, that then trying to directly apply it to a small startup which is just starting to collect data does not work at all. So, well, I mean, you'd think it's obvious, but you tend to sort of go down the path of comfort, and then you quickly realize that you need to unlearn a few things and then do things that you thought were not the right thing to do. So really just straddling these worlds with lots of failures there and learnings.
Awesome. Love it, guys.
Guys,
Thank you so much for the very enlightening and spirited discussion. I hope all of the people who've joined are going to take back the learnings and apply it to their teams and organizations. So thank you so much for joining again, and have a great evening.
thank you. Thank you so much, panelists. We're sorry,
Thank you.
Geeta, we took some time away from you, but the hope is that we end the conference with something positive.